In the last lecture, we have talked about Kubernetes for the first time after going through containerization and working with Docker. So Docker, in the Docker lesson, we've looked into how to create container images, what are containers, how to create container images, and also what container registries are, including how to create container images and push them to a registry. We then looked into Kubernetes the first time. We've seen that the interaction with Kubernetes can be easy using kubectl or kubectl. That this command line utility is one of the ways to interact with the Kubernetes cluster. We've then looked into creating a namespace. We've looked into how a configuration context can be created that refers to a namespace and how that namespace can be used. So for example, we've created the K8s training namespace, and all the actions we perform in the Kubernetes cluster will be performed in that particular namespace. Especially when multiple projects use the same Kubernetes cluster, this is a very handy thing. Otherwise, all the commands would be executed in the default namespace. So that namespace could be a crowded place after a while. So using namespaces to separate tenants, so to say, is a good methodology if multiple projects are to be hosted on a single Kubernetes cluster. We looked into how to create an interactive pod, which means creating a container inside of a pod. We've learned that a pod is the smallest entity that you can schedule in a Kubernetes cluster, that a pod consists of one or multiple containers, and we've also created an interactive container which becomes handy like whenever debugging or you want to try something out and you need a perspective from within a Kubernetes cluster. Such an interactive pod is very useful. We've started a simple web application as a pod, and I'll create this, make this a bit bigger. Yeah, so we've run a pod, we've looked into how to get the logs, retrieve a bit of information about a running pod by describing it. For example, we deleted the pod and then concluded. So in this lecture, we'll look into replica sets and services. So a pod is already a very nice construct, as it allows us to describe several containers. We've also seen that if a container fails within a pod, depending on the restart policy, you'll get some degree of self-healing because the pod is rescheduled or the container restarted. Now, with a single pod under the control of an application developer, a little bit more control would be nice, and the next construct that uses pods is replica sets. Replica sets are very useful if dealing with stateless applications, and we will later see that the replica set is also means to a higher level construct called a deployment. Therefore, the replica set will not be the way how we deploy applications in the end. We'll rather use a deployment, but it is a structure that we should have a look at for a little while to understand how a deployment makes use of replica sets and what the behavior of a replica set is. As in general in this course, the depth in which we cover the topics is quite shallow, as I think a first iteration of learning Kubernetes should be to understand the major outlines and then step by step increase the depth. So let's dive into ReplicaSets with a side note that we are aware that there's much more to know about ReplicaSets than it is covered here. All right,